Hello everyone, this is Yash, BTech CSE student at LIT, and today I'll be looking at the question first missing positive. Given an unsorted integer array nums, return the smallest positive integer that is not present in nums. You must implement an algorithm that runs in big O of n time and uses big O of 1 auxiliary space. Let's first look at the naive approach that uses extra space. What we are going to do here is first is we are going to find the max element of the array using this function nums dot begin comma nums dot end. So what this does is it finds the max element of the array, and now we are going to check if our max is less than 1, because if our max element is less than 1, then our answer should be 1 itself. And what we can learn from the constraints is that the number of integers present in the array is in the range 1 and 10 to the power 5, whereas our constraint of integer value is int max and int min. So instead of creating a array of something 2 billion values, what we are going to do is use this constraint to our advantage. We will check if our max value is greater than 3, 4, 5. Yeah, that is 10 to the power 5 plus 1. We are going to check if our max value is greater than that and going to set our max value as this. Once done, we are going to check whether our max value, we are going to create another map, like map using calloc. We are going to calloc, instead of using an integer we can use a bool array to reduce the space complexity. Now what we are going to do is calloc an array. The size of bool is 1, so I am writing it manually instead of using size of function. And how much size do we need is max plus 1. For example, in this case the answer should be 2, but if we don't create a map for max plus 1, what it does is it will return 1 as the answer, because our default case is going to run that way. So to tackle this problem, what we are going to do, instead of just adding a max plus 1, we are going to increment our max value here. Now we have a map of these. Now we iterate through all our values inside a parsed array and set these value as map of, if we have to check whether the value of itr is greater than 0 and itr's value is less than this, because if our constraint runs, then we have to check that it doesn't exceed the limit or the index size of the array and give us an heap buffer overflow error. If itr is greater than 0, so that it doesn't go to -1 and return an address sanitizer. And this, if our edge case runs and the size is this, but the integer value captured is maybe more than this or int max itself. Now what we are going to do is set as map itr equals to true. Our maps itr is true. That means our values are now set. After this loop, we are going to iterate through, iterate through these values. Itr equals to 0, itr less than max, itr plus plus. We are going to iterate through our map and check which value is negative, false. If our maps itr equals to false, that means that particular index is not ticked as true, so that value is missing, and we return itr plus 1 as we stored the value as map of itr minus 1 here. Done for this, and now simply return nums dot size, because for the edge case, in this case we can see all the positive value from 1, 2, 3, 1 and 2 are present, but what we need is 3. So this won't run for this case. Instead, what we are going to do is check using this, return the size of the array, and done. Let's try to submit this. Okay, it's a good approach, but it uses extra space. Now let's use this cyclic sort approach. What we are going to do here is we are going to use two variables, one to store the size of the array and one to iterate through all the values, and we are going to run a while loop through it, itr less than size. Now what the value does is, when we are on the 0th index, it checks whether the value at the 0 index is 1. So what it does, we get a 1. 1 minus 1 should be 0. So the correct index at which 1 should be is 0. Same goes for 2. Let's use the test case number 2. The correct index for 3 should be 2. That is the value minus 1. So 3 minus 1 equals to 2. So the 3 values should be stored at second index. So the correct index is equal to nums itr minus 1. Okay, and since there is a case where our value can be int min, so to tackle that we are going to use long here. Now a simple base case, that is if our correct index is less than 0 or our correct index is greater than the size, or nums itr is equal to nums correct index. In all these cases we have to increment itr because there is no point of solving this request. If the correct index we calculated is less than 0, then we don't need to put it inside the array, as it is not possible. Same for the value if it is more than or equal to size, and if the value at the correct index is equal to the value at the current index, then we have to increment itr as well. Else, if none of these cases occur, we are going to swap our values at the correct index and the current index, like this. Simple condition runs, and according to this, using this loop, we have created a cyclic sort. We have sorted the array. Now we are going to simply iterate through all the values itr plus plus, and if the value at the index is not equal to the value of index plus 1, then we are going to return itr plus 1, because the correct index should be, the correct index at which the value should be is the value of the index, the value of the number minus 1. So the value at the index should be the value of index plus 1 simply. And now our base case will be return size plus 1 to tackle the case of 1. Like in this case the value should be 1, it's at the correct index, but our answer is coming out to be 2 because the first missing positive is 2. So we simply return size plus 1. Okay. Long int. Wait. We need to do a type conversion here to make sure we don't see this error. Okay, now I'll be posting both the solutions in the description. You can check it out. Thank you.